talk a little bit about the class, then maybe do some questions. Are we rolling?
Yes.
Okay, good. So welcome. This is Math 392, Linear Algebra and Vector Calculus for Engineers. First thing we're going to do is read through the syllabus, as I said. So let's get started. My name is Jhevon Smith, as you see here. Call me Jhevon is fine. I don't have a PhD, so I'm not a doctor or professor yet. So call me Jhevon is fine. My email contact is there, Jhevon@gmail. It's better that you contact me there. In fact, you're required to contact me by this email. We'll get to that later on. Office hours is the hour immediately following class. So right after class, I'll be able to meet with students for an hour or so. Because I work right up to before class, so I can't really meet before, so it'll have to be after class. And by appointment, right? So if you want to meet with me, you should let me know. You don't like waiting around for students and no students show up, right? That's my website page. I'll be referring you to that page in the future, because I'll be posting things online every now and then for you guys to download. The text for this class is the Stewart's Calculus, Essential Calculus, first edition. It should be a book that you guys already have, because it's the same book that you guys use for Test 1, 2, and 3. We're going to be doing some of the later chapters in that book. The second book that we'll be using later on in the semester is Linear Algebra for Calculus by Heuvers. But that's for the last part of the class. Okay, there's the math department location and its website. Calculators not permitted in this class. Grades are assigned according to the following scale. You can see the scale there. It's 0. So let's talk some more about administration. Okay. So 392, as you can see from the title, it's a class for engineers. So if you're here, chances are you're an engineer. Physics majors will also find this class very useful as well. You need a C to pass the class. If you just need credit, a D will do. But if you're in engineering or certain other majors, they might actually require for you to do better. So your engineering advisor might say, oh, you need a B to get into the engineering program or whatever. So you should know where you should be. But like I said, if you're aiming for an A, right, you're fine either way, and you're my kind of student. But it's going to be really important in engineering later on, and I'll talk a little bit more about that. The distribution of grades for this class is 40% of your overall grade comes from the final. That's department policy. I can't change that. And the 60% that's left over comes from your in-class work. So that'll be from quizzes, in-class tests, and what I call here participation, which is basically, I'm going to give you credit for showing up and doing your homework, right? So it's very nice. You get 10% of your in-class grade for that. So you have 30% for quizzes. In general, I want to give maybe one quiz per week, right? So every week you're going to have either a quiz or a test. That's how I'm going to run it, right? I'm just going to have you guys keep on studying throughout the semester. I'll drop the worst 2 quizzes, and I plan on giving 4 exams, and I'll drop the worst exam as well. 10% comes from participation, so you get 5% for attendance and 5% for homework. And here I say how I compute your final grade. Extra credit, I do not plan on giving extra credit or makeup exams. But since I'm trying something this semester new with the whole camera thing, I'll probably give a student extra credit if they work the camera or whatever. Yeah, read the 5 right? Attendance, right? So here I give you the attendance. Show up all the time, or I might deduct points. Not really, I just say that. But if your attendance is great, it really helps me to judge what kind of student you are, and I'm more likely to be lenient later on, right? So if I see that your test grades aren't that good, but I know that you're always showing up, you're always doing your homework, I might take that into consideration, right? So that's how that will work. You should be careful. One thing about attendance, though, is if you have 5 unexcused absences, I can actually drop you from the class. So be careful not to accumulate too many absences. You have up to a day after you're absent to notify me by email why you were absent, so that way I can make it an excused absence and it'll be fine. Again, here I say no makeups, no quizzes. Expectations. do not slack off, right? More of this in class, I said. I realized that of all the classes I've taught, 392, this seems to be a class where the students kind of slack off for the first half of the semester, and then they sort of try to cram and make up for it in the last half of the semester. I don't really see that otherwise, but I guess at this point you sort of get complacent. I mean, you've been through Calc 1, 2, and 3, and you're like, okay, I got this math thing. And you're like, okay, you know, I'm almost there now. This is my last math class, and you sort of take it easy. I do not recommend this. The class is not going to be difficult, relatively speaking, especially if you're an engineer. It's not going to be the hardest class you've taken, but it is something that you're going to want to work hard at. It is something you're going to want to know very well, and I will talk more about that later on, why you want to know it very well. I'll give you homework pretty much every class. It'll pretty much always be due by the next class, and you have up until a week after the due date to hand it in. And I'll grade you down, but I'll give you some credit for it. When you hand in homework, there are some stipulations, and I will deduct points if you do not follow these stipulations, basically. Your homework should be stapled if it consists of several pages, right? You should properly label your homework, right? Make sure you have your name, the topic number, the section, right? And the difference between topic number and section number you will see from the assignment list later on. So by topic number, I'm talking this number here. Section number is actually the section on the chapter in the textbook. So be aware of that. They're two different things. I expect you to have both numbers on it, because sometimes students, they mislabel their homework. And it's less likely for you to mislabel two things instead of one. Right, only one topic per stapled group, so if you're doing homework for topic 1 and homework for topic 2, and you're handing in both at the same time, do not staple them all in one thing. Staple the topic 1 group together separately from the topic 2 group. Okay, do not group different topics of homework, right, for our organization purposes. Please be neat, write legibly, okay? So all these things are very important, and I will actually deduct points if you do not follow these guidelines, okay? Just so I warned you. Another thing, I do expect you to remember the math you've done before. The prerequisite for this class is Calculus 3, and it is actually a real prerequisite. A lot of times you see prerequisites for class and I don't even know why they're prerequisites. Like for example, you will see that on the math department website that 391 is a prerequisite for this class. You don't need 391 for this class. I don't know why that's there. But Calc 3, you need Calc 3 for this class. Most of this class is Calc 3. In fact, if you're very good at Calc 3, this class will be very easy. If you're not good at Calc 3, the class will be difficult. Right? It's actually a pretty big deal. In fact, if you notice from the syllabus, a lot of topics are from Calc 3, right? Chapter 10 is something you do in Calc 3. Chapter 12 is something you do in Calc 3. And they think it's so important that they put it back in the syllabus. Okay? Calc 3 is pretty important. Section 10.6 from your textbook is not in the official syllabus, but I do recommend that you review it. That's the section on graphing surfaces and quadratic surfaces and cylinders and things like that. You're going to need to be able to draw pictures, right? If I give you the equation of a cylinder, you should be able to recognize that it's the equation of a cylinder and graph it, right? Between some limits, right? If I give you the equation of a cone, you should know, oh, that's a cone, and be able to graph it, right? You're going to be able to need to know how to do these things. So it's not in the syllabus, but you will need to know it. What else is there? So yeah, I basically will expect you to know all the math you've done before. Your differentiation and integration rules, you're going to need to remember them, right? So everything from Calc 1, 2, and 3, they're coming back. Calc 3 is very important though. That's one of the most important. Repeat the following to yourself 10 times a day. 5 times when you wake up, 5 times when you go to sleep. I must not cancel across sums. I must not distribute powers across sums. I must not divide by 0. All these are blasphemy. Okay? I will use brackets appropriately. What do I mean by these? So for example, you see something like x plus 2 divided by 2, you cannot do this. Okay? I have to say it. Because students in 392 have actually done things like this before. I just want to make sure that you don't do anything. So you cannot cancel across sums. You cannot distribute powers across sums. So if you see something like x plus 2 all squared, it is not the same as x squared plus 2 squared. right? That is not correct. You cannot distribute powers across elements. You cannot divide by 0, right? So if you see something like this, you made a mistake. It's wrong, right? Don't write it, and don't tell me that it's 0. It's not 0. It makes no sense, okay? Use brackets appropriately. So if you want to write x plus 2 squared, this is actually different from this, okay? It actually makes a difference, okay? And sometimes students will write things like these, and in their head they'll know what they mean. But under the pressure of an exam, right, if you're writing really fast and you're under pressure, and you look back up and the brackets aren't there, you'll forget that they were supposed to be there. I've seen that happen all the time. So do not forget your brackets, okay? So I said to repeat that mantra to yourself 10 times a day. Sort of a joke, but the part in bold afterwards is not a joke. If you make any one of these mistakes on a quiz or a test, I give you 0. I don't care how you did it on anything else. Okay? Do not make one of these mistakes. They cause a lot of pain and suffering.
Yeah. That's actually exactly the question.
Yes?
Is that a 0 for the whole exam, or that just question?
The whole exam or in the whole quiz?
What was all the part?
The whole exam?
Yes, the whole exam.
So if it's one question?
Yes, I give you 0 for the whole exam. I stop grading your exam, I give you a 0.
Okay.
Okay.
Thank you.
Yeah. So make sure you do not. I'm warning you. Okay? Because it's actually it's an epidemic these days. It causes a lot of lost points. The first time I was teaching, I used to see students doing this, and I'm like, what? Why are they doing this? This is calculus. They should know not to do this. And people like fail exams because of mistakes like this. And I started pulling, and it would be like a lot of people. In like a class of size 30, you have like 10, 12, 15 people doing things like this. And I started putting these things in my syllabus and giving people 0, and then it dropped to like maybe one person would do it one time, and then never again. So yeah, I'm serious about this. Do not do this, right? You're better than this, okay? Contact. I need everyone to email me by the end of today. Tell me your name, the class you're in, and its section, because I will be making electronic reports that I'll email to the class. I'll also be emailing you important information and advice when needed, so I need your contact information to send you that information. You should be using your college email, but if you don't use it, it's fine to send me a personal email. I'm not going to spam you, I'm just sending you stuff for the class, right? So send me an email that you use regularly, and so that I can get in contact with you. Pretty important, okay? Feedback. I encourage you to give me feedback, right? So I'm not just up here to talk. I'm not just here to teach and get a paycheck. I actually want you to learn. So if anything I'm doing that you think is a problem, you should let me know about it, and we will address these issues, and I will tailor my teaching according to the needs of the class, basically. That's what I want to do. So please, I encourage feedback. You don't have to be anonymous when you give me feedback. I'm not going to grade you down for it. You're actually helping me out. But if you want to remain anonymous, there is an anonymous feedback option on my website. So you can actually give me feedback without actually giving me your name if you're afraid. So yeah, I encourage feedback. Please talk to me. Let me know how the class is going, if you're understanding everything, if you think anything can be improved, or anything you like and you think I should do that more. Right? Just let me know. Okay? And make it constructive, please. Don't just email me and say, your teaching sucks! Right? Tell me your teaching sucks because you do this, you do that, you don't do this. I thought this would be better. Okay? Just make it constructive, and that would be good. Help, right? You can always use a little help. We have tutoring services here at City College. In the Marshall Building, we have a math tutoring center. That location is there. I recognize some of your faces from the tutoring center, so you guys know about it. The schedule this semester is there. And there are also online resources available, things like mathhelpforum.com. I used to help out a lot there when I was an undergrad student. And there are a lot of people there who like help you out with math. It's like real time. It's like a forum, right? You ask questions and someone walks you through it and helps you out. Another great site that I like is Wolfram Alpha. If you haven't heard of it, it's a pretty good site. It will actually, like, you'd use that to check your answers. So if you want to do like extra work, practice some of the even problems, the answers aren't in the back of the book, you can actually like type them into Wolfram Alpha, right? I mean, it's sort of intuitive. So for example, if you want to do something like the integral of x plus 2 dx, then you pretty much go into Wolfram Alpha and you type int, that's short for integral of x plus 2 dx, you press enter, and it will actually give you the answer. Right? It will tell you it's x squared over 2 plus 2x plus c. Right? And sometimes it actually draw a picture for you and say, oh, what you're actually doing is computing the area under x plus 2. If you give it a definite integral, and it's really a smart computer. So it will help you compute some things. So if you're not sure about your answers, you can use that to check your answer. It's a really good site. Other sites that you can check out is, YouTube. They have lecture videos on YouTube, Khan Academy. There are a lot of things online there are a lot of resources online that you could check out. So I encourage you to do that if you need to. Other resources are your classmates, right? You're all in this together, so help each other out, right? It would be good if you get the contact information for one other person, right? If you miss a class, you miss notes or something like that. They can help you. You guys can study together. It's good studying in groups. And of course, there's always me. You can come and ask me. You're probably getting a Captain Blood impression of me since I'm giving you a 0, but
yeah.
I'm really approachable. Don't let that discourage you from asking me for help. Okay. Something else that's new this semester is recitation sessions. So for this semester, the math department decided to make jumbo-sized classes for some classes, right? These are like the physics-sized class, like 100 students per class. So they thought that if they're doing classes like that, it would be pretty good to have review sessions, right? So they actually instituted some review sessions, and there's actually a review session for 392. That will be on, they start this Wednesday. They're 50-minute long sessions, and you pretty much do problem solving, question and answers, right? You'll have a teacher's aide there, and you'll answer a question and work through problems
They
together.
begin this Wednesday, but we just barely started.
Hmm?
They begin this Wednesday for this class, but we just barely started, so how could they?
In case you learn anything today, that you're going to on Wednesday.
Okay.
It doesn't hurt. If you, I don't know, some of you might have questions. I mean, probably not in this class, but they are doing it for other classes.
Oh.
If you're like an algebra student, you're just out of high school, you're afraid. It's possible that you need help by Wednesday. Some people need help. Come on. So
Where do
yeah.
you get the schedule for the recitation?
Huh?
Where do you get the schedule for the recitation?
Oh, that was in a mass email to math department faculty. They probably posted it on the door by now, but I don't know. I got this in an email. I don't know if they posted it publicly somewhere yet, but that's the schedule for 392. Class rules: silence your cell phones, no eating, drinking is okay. If you need your coffee, I'm fine with that. Academic integrity: don't cheat, basically. I don't like cheaters. Here is the syllabus. You will notice that there are sections from Calculus 3 in there again. You'll know that notice that we have part 1 and part 2 in the syllabus. Part 1 is vector calculus. Part 2 is linear algebra. And here are the course learning outcomes, basically for accreditation purposes. So I'm required by law to hand this out the first day of class, so you know what you're supposed to be learning by the end of this class. So you should keep that. The last page is a questionnaire that you guys should fill out. Just flip it off and give it back to me.
Okay.
And that is it. So that's how the class is going to be run. Yes. Are there
For
any
Wednesday, do you want the homework for 10.7?
Well, homework is basically assigned as I finish a class. So if I finish a section today, then the homework will be due on Wednesday. So it depends on what we get through.
I think your term is off.
Huh?
The term off for present means.
Yeah, it's fine.
Okay, okay.
It's not. It hasn't changed. Yeah. Are there any other questions, concerns, comments?
And how long do we have to send in the homework?
Usually when I finish a section in this class, the homework for that section is due the following class, and you have until a week after that date, or before the next test, to hand in the homework. right? Whichever one comes first. Yeah. You will lose points for latest, but you will get partial credit. Any other questions? Come again? Yeah, I give you credit for attendance, yes. So you will get, attendance is like a 2-point scale. If you're early, I give you 2 points. If you're late, I give you 1 point. If you're absent, I give you 0. Any other questions?
Can I get 2 copies of the syllabus back?
Sure, I have it. Other questions? No questions, no concerns?
Question?
Yes.
The test, is that like partial of the period or the whole class section?
I think the first test is a full period test. The others are partial.
Okay.
They'd be like 45 minutes, 50 minutes.
Okay.
And the syllabus tells you what topics you'll be tested on, so you already know, right? So when you finish the first 5, you have an exam. When you finish up to here, you have exam 2, and so on and so forth. So the in-class tests are not cumulative, but the final is cumulative. And it's a departmental final. I'm not writing your final, the math department writes it.
And how advanced do we announce that we will have a test in 1 week or 2
Yeah, pretty much about a week. So about a week before a test, I'll actually give you a review sheet.
Oh, you
Or I will tell you what problems to review
Oh,
from
so
some
our test-
certain
So our
sources.
test will be based on that sheet then?
Yeah,
Oh, okay.
yeah, I'll be giving you a review sheet. Any other questions? Okay, so like I said, this class will not be the hardest class, hopefully. Like I said, if you're very good at Calc 3, you should have a pretty easy time in this class. But you know, over the break, people forget a lot and so on and so forth. So before we jump into it, if there are no other questions, let's just talk a little bit about the goals of this class. As you see, math majors like me, we can actually study math just for the enjoyment of studying math. But I understand that not everyone is like that. A lot of people want to know, what's the use? What's the point? Why are we doing this? Right? So I think I'll say a few words on that. And just so I'm not accused of not teaching you what I should be teaching, just so that you understand the scope of this class, it's for engineers.
Yeah.
Okay, so there's not going to be a lot of theory. I'm not going to prove all the theorems, if any, right? So I'm not going to like prove anything. Most of you probably don't even know about proof factors, so it doesn't make any sense. Right? I'm just going to tell you basically what an engineer needs to know, right? You guys are engineers in training, so I'm pretty much going to show you what an engineer is supposed to do. You take the hard work that mathematicians do and you use it to make money, right? That's what you do, right? So I'm just going to tell you the bare bones nitty gritty. You need to know this in order to do this, right? And you move on. The class is very computational theoretical, meaning we're not really going to do any of the applications. I'm just going to show you the mechanics of the things you would do to apply it. So, for example, if we're doing vector calculus, you might wonder what's vector calculus for. It's actually pretty useful in applied math and physics, right? So engineering and physical sciences, it's a pretty useful tool. Pretty much anything that you can plot using vector fields, so you're using fluid dynamics, you'd use vector calculus, and you also use it in electromagnetics. Right, you use a lot of 392 in electromagnetics at this course, so if you have to take electromagnetics, you really need to know this. It's super important. We're doing it all the time in electromagnetics. Yeah, fluid mechanics, solid mechanics, you'll need it. A lot of things in physics, especially if you're doing electromagnetism, things like that. Anything that you can model using a vector field, vector calculus is useful for, right? So electric currents, things like that. Electric fields, you'll be able to use vector calculus for, right? Fluid fields, you'll be able to use vector calculus for. So that's what it's important for, but we're not actually going to apply it in any of these circumstances. I'm just going to show you the computations that you would do to compute certain things that you would apply. to it, right? We're not going to focus on the applications. I'll mention them from time to time so you can see why they're useful and how you would use it in practice, but we're not actually going to do them. I'm just going to tell you, compute this, compute that, compute this, find this, do that, right? And you're not even going to know why, but right. But when you, in the future, when you do these classes that requires you to do these things, you know the mechanics of how to do it. That's what this class is for. It's just showing you the mechanics of how to use vector calculus and linear algebra. Linear algebra is the second part of this course. This is about a third of the course, maybe, in terms of topics. Now, linear algebra is everywhere. If you're a math major, like pretty much every class you do after a certain point needs some form of linear algebra. But we are only going to use it as far as solving problems is concerned. Systems of equations, we're going to be able to use linear algebra to solve those. Systems of differential equations, we're going to use linear algebra to solve those. And you actually don't need to know anything about differential equations to do it. We're just going to apply this really nice formula with some commutations. Right? So that's what these things are for. And are there any other questions, concerns? Oh yeah, you're supposed to fill that and hand it in before you leave. So the questionnaires you give in before you leave. If there are no other questions, we will actually begin.
Is the final exam same for every class?
All the day sections have the same final exam. They're written by the math department. This is a day section, yes. Any class that starts before 4 p.m. is a day section. And the math department writes the final. Any other questions?
So the final has the same weight as the other exams?
No, final is 40% of your overall grade. The other exams are worth 60% of your in-class grade. Okay, let's begin. First topic is 10.7, something we did in Calc 3, but I need to jog your memory. It's called Parametrize curves. Okay, so we're going to talk about parametrizing curves.
Okay.
By the way, like I said in my expectations, I expect you to, read ahead, right? Don't slack off. Try to get your brain working on stuff before. I mean, as you can see, even I read ahead and read my own notes, right? I prepared for class before coming to class, and I know everything, right? So how much more should you guys be learning if you don't know everything, right? But we're going to start with parameterized curves, and we're just going to go over some basic definitions just to jog your memory. Called a vector curve RT This is a vector curve in free space, right? So you can write it like these, where these are just functions of times, right? These guys are called components, right? So this is called the x component, this is the y component, this is the z component, right? So this tells you what the x coordinate is doing, what the y coordinate is doing, what the z coordinate is doing, and at any given time, they will tell you how to plot a point on this curve in free space. Right, so for example, this guy's a vector curve, right? He's going to give you some way to plot curves in space. Another example, I can say, who can tell me what that vector curve looks like?
Cylinder?
It's a circle. It's not a cylinder. Where is the circle?
One.
One.
In the plane z equals 1.
Yeah.
right?
Yeah.
So things like that. Right? So this is actually a curve in space that we can actually represent using vector representation.
Space curve.
It's a space curve, or a parametrized curve, right? There are many notations. We can write R of t as x equals x of t, y equals y of t, z equals z of t. These are called parametric equations. And this is called a parametrize. So when you say you're making a parametrized curve or parametrization of a curve, you're just talking about expressing that curve as parametric equations, where you just give us separate equations each for x, y, and z. So here, I could parametrize this and just write it as, x equals e to the t, y equals ln t, z equals t squared plus 1, right? And if I give you this or this, they mean the same thing. Or it's just a different form. This is called the parametric form because you use parametric equations. Okay? Let's talk about doing calculus on vector curves or parametric curves. Right? Of course, when I say calculus, I mean limits, derivatives, integrals. Okay, so as you may recall from Calc 3, these are done component-wise. Right? So, for example, if R of t is x of t, y of t, for example, then I can say d dt of R of t, or I can actually write R prime of t. This is just d dt of this function, d dt of that function. Or you can write it as x prime of t, y prime of t. So the derivative of a vector curve is just the derivative of each components, provided they exist, that we call the derivative. Right? So here I just wrote that derivative. I probably should have done limits first, but it's basically the same thing. If I say limit as t goes to t0 of R of t, this is just the limit as t goes to t0 of x of t, limit t goes to t0. Right? Same thing for integrals. If I say the integral of R of t dt, this is just going to be the integral of x t dt. Right. And of course, there's always a plus c.
Yeah.
And the c in this case would also be a constant vector.
I have a question. Why is it ddx x of t and not ddy y of t?
It should be ddt. Sorry, that's a
Okay.
typo. Yeah. Derivative is with respect to the independent variable. to talk about. So that's calculus. Any questions on that? Do I actually need to do an example? All right, so if you remember your derivative rules, you'll be able to do it. Just apply component ones.
Wait, do we need to know the harmonic equation? Like, I mean, we know it, but do we need to be able? I mean, do we need to use harmonic
No,
equations?
I'm not,
Okay.
no, I'm not going to mention that specifically. No. Any other questions? Everyone okay so far? Okay, let's continue. Another thing we're going to need to know how to do is to actually parametrize curves. So if I actually describe a curve to you, could you actually write it as parameters? Right, so we are going to talk about. Now there are many ways to parametrize curves, and there are many ways to parametrize different kinds of curves, but we're going to talk about some specific examples that we're going to be using often, right? So how you parametrize things are not going to be limited to what I'm doing here, but in this class it's pretty much going to cover everything you ever need to parametrize. It's talking about parametrizing circles. Right? So you might remember from Calc 3, parameterize a circle, you use cosine and sine, right? Yep. So for example, the unit circle being 2, you know you can parameterize that by x equals cosine t, y equals sine t, t goes from 0 to 2. Right? So that's one thing, right? So that's one thing with circles. So, for example, let's say I have RT. Oh, we actually did this one. Right? So if you see this curve and give you this in a problem, you should recognize that it's a circle because you see that, oh, the x component is cosine, the y component is sine. That reminds you of a circle. And so this tells you here the z component is a constant 1. And that's how you would know that this is just a circle in the plane z equals 1. Right? If this were a t instead of a constant, then you would get something like a spiral. Right? Because the z would be moving up and down while the x and y are going in a circle. So you end up with a spiral. So if I ask you to graph a spiral, you should be able to come up with something like that. Right? Or jump between one or the other. You need to be able to jump between the picture and the algebraic expression. Right? So I expect you to know how to do that. So in general, if you have x equal to a plus So if you see any expressions like these with sines and cosines, odds are we're talking about a circle, right? If the r here is the same, you get a circle. If the constant in front of the sine and cosine are different, you get an ellipse. Okay?
What? I didn't hear you.
If the coefficients of these, r is also an r,
Yeah.
right? If the coefficients of the cosine are different, let me just write that down. Let me write it down. So if you see something like x equals a plus b plus t, y equals c plus b sine t, b not equals c, then this gives you an ellipse. Right? not a circle. And the major axis is determined by the bigger one. Okay? Yes?
Did you mean to put B is not equal to C or B is not equal to D?
B is not equal to D.
What do you mean by major axis?
Okay?
What do you mean by major axis?
The one that's elongated.
Oh, okay.
Okay. If you have like this, your major axis is this guy, your minor axis is this guy.
Yeah.
Right? The bigger number, right? So if the bigger numbers with the y, then you know that it's going to be elongated this way. The bigger numbers on the coefficient with the x, it's going to be elongated that way. And the center here is given by the A, C. Okay, so that's how we get an ellipse. This is how we get a circle.
And if B and D were the same, it would be a circle, right?
Yeah, B and D are the same. You're back in this situation where you have R and R. So that just means you get a circle. It means that your major axis and your minor axis would be the same length, so that means you have just the radius of the circle. Yes?
For this class, how complicated does it get with like if we had to do this, but instead of sine t, we had one of them was like sine 4t, and the other one was cosine t. Would we have something like that?
In general, no. Like, I wouldn't expect you to be able to draw that, for example. But of course, if I give you something like that and ask you to like differentiate it, then sure. Yeah, like graphing something like that. Okay, so that's an ellipse. Can anyone prove why that gives a circle? Anyone think they know how to do it?
Because they both have R.
Huh?
Because they both have R.
Like, not really, yeah, but I don't know. I said this is the equation, and I said specifically this gives you a circle with a specific center and a specific radius. Why is that?
Polar coordinates.
Polar coordinates.
X squared plus R squared, Y squared is 1.
Exactly. X squared plus Y squared.
Polar coordinates, yeah.
Right? So if X is this, if I take X squared plus Y squared, then that would be, what would that be?
Cos 2 squared.
Well, when you work it all out, yes, it's going to be R squared. Well, let me, yeah, it's going to give you R squared. It's actually going to give you, if you work it out, it's going to be X minus A squared plus Y minus B squared gives you R squared. And if you actually want to see it, if I know that X equals A plus R plus then this would mean X minus A is equal to R cosine. Y minus B is equal to R sine. If I square these two, and now I add them, right? So I would get X minus A squared plus Y minus B squared would give me R squared cosine squared plus R squared sine squared. R squared is a common factor, which means I can factor it out. I'd be left with cosine squared plus sine squared, which we should remember is 1, and so it's just 1 times R squared. Okay. So we know that this, we can actually derive a circle from this, right? So you should know how to do that, but in general, with things like these, you're just supposed to look at it and know, oh, that's a circle. You should be able to just recognize it by looking at it. And the thing that's going to hint you that it's a circle is sine and cosine. Another thing that we're going to need to know how to parameterize are line segments. Okay, so if we want a line segment from X initial, Y initial, Z initial to X final, Y final, Z final. This is given by And this parameterization works for t goes from 0 to 1. Right? Now, I like to write out the formula that way. Your book gives you a more concise formula back in the Calc 3 section. But to me, it's easier to think of it this way. But basically what you do is you start at the initial point and you add the difference between the final and initial point times t. So what happens is when t is 0, all these terms are gone, and you're at the initial point. When t is 1, then you'd have the initial would subtract the initial, and you end up with the final point. In practice, it's actually a lot. So when you think of it as the difference between the 2 points, it's actually a lot easier in practice to figure them out. So for example, if I want to do the line segment from 1 to 7 and I want to parameterize that line segment, right? I want to be able to write it as a vector curve, which will be important. Then what I would do is say the x guy, what do? You write down the initial point, right? So I start at 1, and then what you do is you figure out what do you need to add or subtract in order to get to -3. What's that? -4, right? So just -4, attach a t to it. The y, start at 2. What do you need to do to 2 to get to 5?
Plus 3.
You have to add 3, attach a t to that. Z starts at 7. What do you need to do to get to 8?
1.
You add 1. And that's the parameterization. So if I give you a vector curve that looks like this, 1 minus 4t, 2 plus 3t, 7 plus t, and I tell you that t goes from 0 to 1, what I'm actually describing is a line segment that goes from this point to that point. And you should be able to recognize that, right? So whenever you have a vector component where all the components are linear functions, you just have a line in your vector space.
If z wasn't bounded, it'd be an infinite line, right?
Yep.
If z wasn't bounded, it'd be an infinite line.
Yeah, if t wasn't bounded, it's infinite, right? So, but when you give it, and with this formula, it will always be 0 to 1, right? If you parameterize it according to this formula, you don't have to think about the limits. It will be 0 to 1 if you want to get to a line segment, right? Because this ensures that you start at the initial point and you end at the final point if you do 0 to 1. So we know how to parameterize circles, we know how to parameterize lines, and everything else falls in the other category. In this course at least, I mean in general, you probably have other tricks, but pretty much everything else, every other curve you'll encounter in this one would use this technique. So you solve for all variables in terms of one guy and make that a parameter, and that is how you parameterize pretty much anything else you will encounter here. I will give you some examples and then we'll close. Yes.
Why 1? Why 1 to 1?
It's just, it's how you do this, right? Because 0 makes you start at xi. If you plug in 1, it makes you end at xf.
But why end at 1? 1 at 2 or 5?
Well, I could. If I put a 2 here, then I'd have to put a half here. It makes the formula ugly. It's just how it's set up.
Oh, so in general it's 1, right?
Yeah.
If you're using this formula, yes. I mean, conceivably there are other ways you think about it to make extra limits, but usually it's too much to worry about. It's easier to just jump in this form and put it 0 to 1 and just move on with your life. A lot of times we're going to talk about intersection curves. So let's say I want to actually intersect x squared plus z squared equals 4. And I want to intersect that with x plus y plus z equals 1. What kind of surface is this?
No.
It's a circular cylinder, right? How would you draw it? What would it look like?
Well, it would be in the x-axis. So it'd be pointing out the y direction.
Okay.
It'd be pointing out in the y direction.
Yeah, it would be running along. And this guy is, what kind of surface is this? It's a plane. How would you graph it?
Points on one and connected.
Yeah,
Yeah.
right.
Yeah.
Let both
Yeah.
of them 2 be 0 at a time, and you get z equals 1, this equals 1, that equals 1. You get this plane. So basically, you have this plane slicing through this cylinder, and I want to know what is the intersection curve.
Equal to-
How do you go about doing that?
Well, first solve for z, then plug in z to the other equation.
You could do that, yeah. So if you're using that technique, you could do that. You could say z equals 1 minus x minus y, and then you say x squared plus. And then what? Right, so you see if you do this,
Make a parameter of, make either parameter of x and y, or y to x.
right, so in this case that's actually going to be annoying though.
Okay.
What you would want to do here is take the fact that this looks like a circle to your advantage.
Yeah,
How would you do that?
Full coordinates.
Polar coordinates here. X would be what?
X would, well, x is equal to r is equal to r times sine
2 cosine,
Okay.
right?
Sorry,
Z would
y.
be 2 sine.
Yeah.
And so I would be able to write y as 1 minus 2 cosine t minus 2 sine.
Yeah. Yeah.
Right? So I could parametrize it that way. So the curve of intersection in this case could look something like this. I think we actually have to. Forgot there was something else I wanted you guys to do. We'll do it next class. Don't worry about it. We'll just continue. Also, eager to jump into the class. So that is one way you can parametrize that curve. Don't worry about what it actually looks like at the moment. Just know how to parametrize it. Right? Being able to find curves like these, they're going to be important later on. Because a lot of times that's what we're going to be doing. We're going to be intersecting surfaces, and then we're going to be doing things on the curves of intersection. So it's going to be important for you to know how to find them. So another How would you parametrize that?
What is the domain for the previous one?
For this,
Yeah.
0 to 2 partitions. Right, because by the time you do that, you're already going all around and you don't need to go. You do repeating.
For that one, you just plug in x to that equation and then just click square. Yeah, yeah, kind of, yeah. You
There's actually an easier way.
Really? There is? Oh.
No completing the square necessary.
It's a verbal then?
Here, right? I know what x is in terms of y. So how about I get z in terms of y as well?
Oh, I see. Okay.
Right? Z would be 4 minus x minus y, right? But I know that x is this. So it's be 4 minus 1 plus y squared minus y. So this would be, we want to simplify that? 4 minus 1. So here I have x and z I have in terms of the last variable y, right? So I wrote all variables in terms of one of the other guys.
Yeah.
And now what do? I just let that guy be the parameter, right? So I can actually parametrize it by y, right? So let y be the parameter. Say y equals t, and then I'd be able to write the curve as my x would be 1 plus t squared, my y would be t, and my z would be 3 t. Right? So one technique is to write all variables in terms of one other variable and let that guy be the parameter. So you can parametrize it in terms of y, and your t value would follow the y values. Because the y is t. Alright, so if you're given a question, I'll tell you exactly what's going on with the y, and the t will have the same behavior because y is in fact t.
Why do we need to say y to the t? Can we just say r
Oh,
of t?
you don't.
Yeah, okay.
You could say r of y and put
Yeah,
y here.
okay.
It's just, it's conventional to use t, because a lot of times we're thinking of these things in terms of time. For example. Another thing, let's say I ask you to to find the intersection points of those two. What kind of thing is this? What is this?
Linear, a line.
It's a line.
Yeah.
What is this?
No, it's particularly, yeah, it's also, it's a plane actually.
It's a plane, right? So I have a plane and a line is shooting through it. I want to know the point where it actually
You just plug it in and
cuts it.
solve for t.
You plug it in, solve for t, and then you can find x and y, basically. Right? So you say your x you know is 2t, so you can replace it here. Your y you know is t, so you just plug it in here. Your z you know is 2, so you plug it in here. Equals 5, so you get 4t minus t plus 6 equals 5, so you get 3t is equal to minus 1, so your t is equal to minus a third. And this implies your x will be minus 2/3, your y will be minus a third, your z 2, which implies minus 2/3. 2 is point of intersection.
It doesn't necessarily have to be in Cartesian coordinate system, it can be in other.
No, it depends.
Okay.
If I ask you for it, then you should go. But if you left it here, it would be. I think we'll stop here. So, my original plan, just to emphasize for Calc 3 was to give you a quiz today on Calc 3. Quiz on the first day, right? Just to scare them. Yeah. But I guess I'll make that for next class. So next class we have a quiz on Calc 3. It won't be graded. The following week, though, I will give you another quiz on Calc 3, and that will be graded.
Okay, so what about Calc 3 the whole
Right?
class?
So, come again?
So the whole class Calc 3? Or
No, it's a quiz. It's going to be 10, 15 minutes quiz. And yeah, so fill out your questionnaires, hand them up, and you can leave. Enjoy the rest of your day.